Mark and I are here this morning to show you how to use a Tinkerbell project. What we're going to do is walk through the documentation with a tool called Vagrant. This is going to run effectively a lab on my laptop, on my Mac Mini here, and it will create two virtual machines, one for the provisioner side of Tinkerbell and one as a machine that we actually want to boot over the network. And as we go along, we'll have a bit of chit chat. We'll sort of talk about what's going on, and maybe we might sort of take it a bit further in a future session, but this really just give you an idea of what it looks like when all the pieces are working together. So we're on the Tinkerbell.org website here, and what we really want to do is drop into the documentation. There's some information that you can get here that tells you about each of the different components and what they do. I'm going to skip ahead to the setup. And here we've got the two options. So the Vagrant option I discussed, and you can also provision this onto Packet if you're a customer, or if you've got some credit, you don't have to run anything locally. So the prerequisites are that if you're using a Mac, a reasonably modern Mac, that you have VirtualBox installed and that your computer supports virtualization. Most Macs will do. If you're on Windows, it's going to be a very similar experience. Some of the commands are what we'll call bash commands. And so you might want to run a tool called git bash, or maybe have a look at something like WSL instead. So I have Vagrant installed, I have VirtualBox. If you're on Linux, there is support with libvirt that you can look at as well. The first step is to clone the main Tink repo, and this is where the deployment artifacts are, and there's a nice Vagrant file in there. If we actually take a look at my computer, I've got a Vagrant file here, and it's got the information for the libvirt option for the Linux users, and down the bottom we've got the data for how to run on a Mac. Now this might change a little bit by the time you see it, as the project's developing quite a bit, but that's what you start off with. And then really there's two commands, because there's two VMs there. Rather than just a straight Vagrant up, we want a Vagrant up for the provisioner. This will take a box image from the internet that has a base of Ubuntu, download it from the internet. I already have that locally cached, so now it's just importing it. And this will create a new VM behind the scenes in VirtualBox. So if I was to go click down here, once it's in there, we'd actually see it listed. We also get a port on our computer that can be used to shell into the Vagrant VM. What will happen is once this is up and running, Vagrant will connect over SSH, it will run a bunch of commands. We're actually now going to be going through the broader setup process for Tinkerbell, right? That involves things like installing Docker, since all of the Tinkerbell services are actually run through Docker. Let me take a quick look at, I think it's the components page. There's a bunch of different services, and these are all run in a Docker Compose file. You'll see that at the end of this download, we'll have it up and running. I mean, Mark, what's your sort of understanding of the different components that we've got here and how they work together?
Sure, yeah. The one thing I wanted to say first is that although we've prepared this local environment that you can use, if you do want to try it out on Packet, so the reason why we create the local environment is because we didn't really want to have it so that people had to pay us to be able to experiment with this. If you are interested in trying it out on Packet, though, you can join us in the Packet community Slack, which is at slack.packet.com. And if you find me in there, my name is mark.packet. You can reach out, tell me about what you're looking to experiment with, and we can help you out with some credits to experiment with Tinkerbell on Packet if you prefer to do that instead of locally. So to talk to the different components, essentially there are a few different steps that are happening here. If we imagine, as Alex just pointed out, that we have the provisioner and then the worker. The provisioner is really doing a lot of the work for us here. The worker is kind of clueless as to what is happening when it starts up. So when the worker starts up, it's going to broadcast to the network DHCP requests. and they're going to be picked up by boots. And I think later we can maybe have a look at how we've set up the network, so you can see how, I think also Alex has an amusing story of how he destroyed his home network by not putting this in the right one. But you'll see how we've got them on the same network, so that when the worker comes up, it starts broadcasting DHCP requests. Boots picks those up, gives the worker an IP, but also importantly points it to the next step, which is the iPXE. And we'll probably be able to see that coming through the logs when that starts happening a little bit later on.
Yeah.
I'm going to skip down to OZ because I think Hagel's a bit of a sort of orthogonal point here. Once the worker gets an IP and gets iPXE, what it's going to do is it's going to boot into OZ in memory. Now, OZ is essentially Alpine Linux. And we can perhaps discuss a little later how we tried this out separately and had to increase the memory on the worker and all that sort of discussion. But OZ is where all the action is going to happen. And once we're in OZ, OZ is going to reach back out to Tink. And Tink is going to say, okay, you have a worker with some identifying feature. In this case, it's going to be a MAC address. Tink will say, oh, I have a workflow that's been created through a template we're going to look at in a minute that matches that MAC address. Now I'm going to send you the instructions, OZ, for what to do. OZ then deals with running what's called action images. I'm going to come back to those in a minute. And very basically, action images are just Docker containers that we've pre-populated or pushed in advance up to the image repository.
Yeah.
And you'll see in there in this hello world example that it's very simple. We run one action image in OZ that just says hello world, but we can also discuss at the end a little bit about, well, here we go. Alex is showing a great example.
Yeah, this example is a more involved example, actually. I wondered if we can find the hello world just here. Yeah, and the thing that I liked is that each action is a Docker image. So what happens is the computer will start up, it will ask for an IP address and what to do next. The provisioner will tell it, here's an IP and I want you to run this firmware to start booting your computer. That firmware runs this OZ process, which is an in-memory Linux. So it's not going to need a disk in the machine even to run, and it doesn't touch the disk initially. It's just going to literally run in memory, and then it will go through a series of Docker images. And the Docker images in this instance, hello world, if I was to Docker run that, it will just literally say, hello world. This is just a classic one that Docker provide. Not going to provision a machine as such, but it gives you an idea of what's happening. And then next, what you might do is create an image that wipes all of the disks in your machine, another one that writes an image that you've created with Packer to the hard disk, and maybe one that makes a couple of customizations. Okay, so back to the Vagrant ARP. Now, at the end of the Vagrant ARP, you're going to get this message, and it's just telling us to finish the install. And then there's a link to this hello world that we've got open. So we'll go to that. So I did Vagrant ARP, but what we need now is Vagrant SSH. And this will give us a shell inside of our VM. Here we are. I believe it's in the Vagrant deploy folder.
Yeah.
We've got a whole bunch of files in there, and what we need to do is, as it says here, we need to run this command, the other half of it, and the next bit says Docker compose up. So we had lots and lots of things happening up above, but then at the end, what we need to do is run a Docker compose stack, and that will deploy all the different microservices. We've got Postgres for data storage, Nginx to actually serve up the artifacts OZ is going to need, like a kernel and the in-memory environment, the init RD. We actually have a container for the Tinkerbell CLI. So that might not be exactly how you're expecting to use a CLI, but for the time being, you can exec into the container and use it from there. Rather than downloading a binary of the CLI and putting it on your machine, you use it from the container.
I think what might also be worth mentioning is, without going into too much detail, some of the stuff that's happening in the Vagrant app. So previously, we had various setup scripts that required quite a lot of manual intervention to get you from from nothing to an environment that had the correct network settings. We changed that so that we could run through Vagrant or through Terraform, basically what's called setup.sh. We're going to do a separate either blog post or video about exactly what's going on in there. But briefly, it's setting up a bunch of the network stuff that I referred to earlier so that the worker and the provisioner are on the same network, and a few other little things. But I think it's just worth pointing out that it's slightly more than just bringing up a VM, and we can probably dig into that another time.
Yeah, there's quite a lot going on. And if you're doing your first time, it might take a few minutes to get there. Now, this is the compose file. We can see we've got the CLI, a metadata service, the DHCP server there. We've got Tink, which is the main gRPC API that is used by the other components, Postgres for our data, Nginx to serve files, and there's a Docker registry. And because we've got these images, they can't be brought in from the Docker Hub, as far as I'm aware. They have to be put in this internal registry, and then that's how they're accessed. So to get to the CLI, as I say, we don't download a release artifact. We don't run that from our PC. We exec into the running container, and then we have this tink command. From there, we've got the hardware command, and we've got the workflow command and the template. These are the basic building blocks that are described in this Hello World. As you can see, the registry needs to have the image in it. So if we just built this workflow and ran it, it wouldn't work. We actually have to, first of all, pull the Hello World Docker image down. Now, what you would be doing is probably building that from scratch rather than pulling it. We then need to just double check what IP address the registry is on. It seems like it might be on all of the IPs. So let's do docker tag. And I think we actually have this in the docs at the moment as to what that's meant to be. So it might be a nice...
I think if you look in env-rc, it's probably in there under, I think it's just provisioner IC, provisioner IP port 80.
Well, here's one.
It might be 1.1.
If we look at Docker images, it looks like it's 1.1. Okay, so what we're now doing is docker tag, which takes hello world and says, right, you now belong in the registry. And then the next job is to push that into that registry, which is running inside the Vagrant VM. Turns out it's already there. It's now correctly tagged.
One additional point there about the registry is that officially speaking, you could just pull all these from the official Docker registry. But what we presume is that your worker will not have access to the internet, which is why we run this internally. I don't think there's anything to stop you from just removing that prefix with the IP in and using the public one. Although I haven't tested that, so we might have to.
Yeah, I do wonder though, because when you look at the template definition, there is no prefix. So I don't know how you could do that unless you put maybe Docker IO behind it.
I think you'd have to, yeah, because I think what it does is it just throws in the provisioner IP that it's given. And if you could change that with Docker IO, maybe that would work. But yeah, untested.
So now it's telling us we need to save this template, and the template is the way I think about this is it's almost like in programming. This is like your class, and your class is just there to sort of define what should happen. When we want to actually have that instantiated and running on a worker, we go through and we do workflow create with the template ID and the machine MAC address or IP. So first of all, we're effectively almost creating the class, the main structure, the blueprint for it. And there's some tokens in here as well that can be substituted. And you can also pass variables into the actions if you want to. What would you use that for? Maybe you want to customize the size of the disk that you're going to use. Maybe you want to customize the initial user password, or all sorts of things. You can pass them into your image there.
I think the other main usage there is just that very often you're going to want to run the same template on many workers.
Yeah.
So substituting the device there is very useful. I think when we get to the hardware definitions later, people will see how there's a one-to-one relationship between there's a one-to-many relationship between a template and a workflow. There's a one-to-one relationship between a workflow and a hardware definition, as far as I understand, but maybe we need to double check that.
Yeah. Now what it's saying is we need to run tink workflow create, and I'll just double check what the parameter is for that with the help message. So we need dash, it looks like, no, this is actually a template. Misspoke there, the workflow template. It looks like we need create, and then it's dash P. Doesn't tell us to define it with a name here. So I could just put the name in anyway. World. Okay, and now what we get back is an ID. So don't actually deal with the workflows and templates according to their names, although they do have a name. It's always this generated GUID from the database. The next step from there, it looks like we need to push some hardware. And this would be to define our worker. Now, because we've used Vagrant, the IP address is going to be, the MAC address is going to be hard coded. We need the MAC because that's how we identify the machine. If you're using Packet, what you would do is you would go to your dashboard once Terraform is run and look for the MAC address there. You also get it at the end of the Terraform provisioning. If you're running on premise in your house, which is what I've also done, you will have a provisioner and you will have a network cable from your switch going off to another machine. In my instance, it's this Dell Optiplex. Now that has got a MAC address, and what I have to do is define the hardware inside the CLI container on my provisioner, and then when that boots up, the boots process knows that it needs to give it an IP address, and it knows to attach it to a workflow. So yeah, you can actually use this at home, and you'll see that you end up with a few subnets, whatever you've got on your main network or on the internet, if that's how you're connecting in. And then there's almost like a bridge or a switch here that is just for one side of the provisioner to broadcast its DHCP on, because you don't want that on your whole network. And then you've got the machines that are going to subscribe to it. Now, do we have a sample hardware here? Or
there's a sample hardware in the setup guide for Vagrant. You could also look in hardware data, but that's a larger one than we're probably going to look at today. Okay,
yeah, let's go back to the Vagrant plan, as we seem to we got directed to the example there, didn't we? Okay, register the hardware. We've got our hello world, and this is actually a bit more helpful. It's got the names in it that we wanted. And now it's saying we're going to do a cat into the hardware JSON. The end of file here means that we can just copy and paste the whole thing, which is really handy. So let's do that.
I think one of the useful things in the guide above as well is where I believe Gianluca wrote this, suggests opening up another window and just streaming the logs from different services so we can see what's happening as we start adding things in.
Yeah. I'm going to need another window for that. Let's see. So what we would do is, again, we can't shell into this machine directly. We've just got to run this vagrant command, vagrant SSH. And let's get your command there. So you've got Docker Composer logs, and it's following the Tink API, the boots process, and Nginx.
Yeah, and I normally add registry on the end as well. It's a bit chatty because we've still got I think it's a 5-second health check set up in there that we need to change, but it does help to see when the images are going in and out.
And then if you didn't particularly want to filter that, there's other ways of doing that. Now this is an error that I've received on a number of times. So what I tend to do here is just Docker PS, see what our containers are, and maybe just follow each one that I'm interested in instead. So if I break the screen up a bit, I want to know the Tink server. That's got all of the RPC that we're doing through the CLI. And then let's also look at next most interesting one is probably going to be boots and maybe nginx as well. We'll keep those two on. What you can see here is we created the template through the CLI that talked to the Tink gRPC API, just logged the line here to tell us that happened. We've got structured logging, which is really useful if you need to aggregate this to Stackdriver or to Elasticsearch, depending on how you manage logs. Okay, so let's get back to where we were going. What we wanted to do is to have this hardware file, and we just created it on the disk. Within the file, there is a MAC address specified, whether this needs UEFI or if it needs BIOS to boot up. And then we've got some of it sort of metadata around this too that you can actually query inside the workflow and then make use of as you provision the computer. Let's do a push of this file. I believe there's an argument needed there, is there? -file. And you probably saw on the Tink logs that just popped up. And we've done inserting into the database. So now Tink hardware list, and you probably see my right-hand side of the screen is going to pop up another log message with that as well. Okay, it's not a list, it's actually the word all. And that one apparently isn't logged. Let's have a look at get. Let's see. No, there isn't a get command. All right, well, this is the hardware that's come back, and we can see it's basically what we put into it. You can also delete one if you got it wrong. And so that hardware is now in the system. In effect, if we go back to my Keynote file that I had, that's like saying when I've got my Dell computer that's going to boot, just define that. We define the template over here. And now what we need to do is, as I said, almost instantiate it and glue it together and say this template and this MAC address, and that's what we're going to call the workflow. So the workflow is almost like the template as an instance of it with the variables replaced like the MAC address. Let's go back. Now we already pushed and tagged our image, so we're good on that front. And here we've got a command we can type in, workflow create, and then we've got the template ID. So let's just refresh our memory. Tink workflow list. Nothing yet, which is what we want. Template list. There's a template, and then we know the MAC address because that's hard coded for Vagrant. If you're working like I was at home, you would obviously have a note of that, and you would replace that value here instead. So
and if you're curious to know where that's hard coded in Vagrant, in case you'd like to change it for any reason, it's actually directly as a variable in the Vagrant file. Great.
And you can also find that in VirtualBox if you want to click through into the UI. We'll see that in a minute, actually. So here's a template ID. It's important that you use the ID that was created. Don't copy and paste any that you see anywhere. Same with the workflow IDs. And now we can copy and paste this, which is effectively almost like a replace of device one. If we look in our code, we see the worker there. And so this is how we're now hooking them up. If you run a workflow and it starts and it finishes and completes successfully, if you want to reboot that machine, it won't run it again. So this is almost tied to an execution. And if you create two workflows and then boot a machine up, it will run both of them back to back. So that's just something to be aware of. When I first used Tinkerbell, I didn't realize that. And I was confused why it wasn't running the workflow. I think at the time it got halfway through and then stopped. It won't rerun it. So you have to create a workflow for every execution that you want to do. All right, so it looks like now we start up the worker. And we will get to that. So we've got our, what do we have here? We've got a provisioner. We want the worker. So Vagrant, SSH worker. If you're deploying onto Packet, you don't have to SSH into the machine. It will just boot up. But you will need to reboot it. Okay. And you can do that for your packet dashboard.
I think it's worth pointing out one of the things that I see that people get quite confused about here now, which is around the Hello World example. Alex touched on it earlier. I think especially if you go and read the initial website copy, we give the impression that the first example you can see is really booting into or provisioning a machine with a new OS. And I think when people look at the worker coming up and see Alpine there, they think, oh, that's it, that's what's happened. But actually,
can you see what we've got now? Actually, I might have to interrupt you here. This is a net boot that's just happened. We've got an IP address. Can you see that? And now we're running iPixie firmware, which is first tried to reach the internet. The internet wasn't connectable. It's now reached into Tinkerbell, and it was given an IP address. It was told what init.rd and kernel to download and what user space to download. It's now executing those files. This is a kernel that's just been launched over the network. Now we do have a terminal here, this one, and this one is from our boots process. We had a DHCP discover, which was broadcast on that network. A request was issued to it, and then it would have been given the firmware to boot. And quite rightly, as Mark was saying, this isn't running. What we're seeing now is not Hello World. This is OSI. OSI is an in-memory Linux. If you think about like a live CD or a rescue USB stick that you'd put in to change a root password or run fdisk or something like that, it's almost exactly the same idea, launched over the network. And in a minute or two, once that root file system has been downloaded, we're booting. And this is not Hello World as a container. This is actually the machine. We see in the logs below, it did actually go and pull our Hello World. It was in progress. It was still in progress. And then it completed successfully. There's a few ways
sorry, go ahead, Alex.
A few ways we can go and find out what happened there. The first I would probably say, the one I find most useful, is workflow events. We've got the workflow ID here, and this will tell us what happened. Now, normally you're going to have a few steps. You might have, I don't know, 2, 10, and each step will execute. One might fail. So this is great diagnostic information, and it also tells you whether it ran, because when you land here, you're just seeing the console. And to really know what happened, to get the logs, we can run docker ps and then -a, which shows us exited containers. From there, we can get the logs by using the first few characters of the container name. If we pipe it to less, we can scroll it, and we'll see, or as you can see here, it says I'm downloading that image from the container registry. We look at Docker images, we see the one that we pushed earlier with the IP address that we were trying to figure out. So Mark, you were saying about how you check the executions.
That's right, yeah. So I think, you know, what's happened a couple of times in the community site, people are like, oh, that's fantastic, I've booted Alpine. It's like, no, not quite. The Hello World example right now, as I was saying to somebody yesterday, is it works, but it's not very impressive. And, you know, really what we've got to here is OSI, the in-memory operating system, which happens to be Alpine, which is given as an environment through which we can start executing action images. And an action image is actually just synonymous with the Docker steps that you saw earlier. So in this case, it would be Hello World, but as Alex alluded to, what you could do, and I know there are a few people in the community that have gone and done this, is you could do a bunch of other commands after that, you know, such as like wiping the disk, partitioning, et cetera, et cetera. So I think that's an important distinction. Now, of course, the question is, well, when do I get to see one of those examples? And I feel like the answer is probably any time now, but we have had some slight miscommunications internally whereby some of them were looking quite promising, and then we made a change, which, as is quite common with early projects like this, broke a lot of stuff, but it's certainly not something we aspire to. And we're looking forward to getting those fixed so that we can show you how to actually go ahead and do what I think most people quite rightly think Tinkerbell's for, which is to get an OS onto a machine.
Yeah.
There are a couple of other sort of resources to point you to as well, people who've successfully done this. I think there's a great blog post coming up from Kinfolk that we're going to share in the community channel. Also, Container Solutions did a whole series about how they got this working on a bunch of Raspberry Pis, and I believe installed GitLab and Anthos, which included rebuilding GitLab for ARM, which is all very exciting. Alex, I know you've done a bunch of work here as well, and you've got some.
I've got a couple of examples that are probably quite interesting. The first approach was myself and one of the developers in a community for Equinix. We're looking at how could we take the internal example that been used for Tinkerbell, because Tinkerbell is a project that effectively was inner source and became open source. So there was a little bit of legacy with it. How could we take what was there, fix it up, and get it running on this? And I actually managed to do that. The screenshot I showed you, the computer on my floor down here, that Dell machine is running Ubuntu that's been provisioned through a Tink workflow. And whilst we had Hello World before, this one actually is quite a bit more involved, but also nice and modular. The first thing we do is we wipe the disks off. Don't want any data there. Next, we do sensible partitions of what we think is a smart scheme for general use. Now, things do get complicated there because you don't necessarily know what kind of hardware you're working with. It could be heterogeneous. It's different every time. So you may need to load in logical device drivers for logical groups. You might need to load in something like ZFS. You may be needing to load in an RAID array driver or other firmware. From that point, you can do your partitions, install a root file system, make it bootable with something like Grub, and then oftentimes you'll want to customize it with something cloud in it. Now that is an approach that was used internally at Packet for images over the last few years. The other approach, which might sort of feel more natural if you're coming from the AWS world, is that you would use something like HashiCorp's Packer to create a disk image. And I've got an example here using Ubuntu 20. And what this does, it takes the standard live server, it runs the installation on it into a disk image, and at the end you get a file. There's also Cloud Config and an auto installer that you can customize it with, say what the Ethernet adapter is, the password, etc., what kind of storage you want. It's pretty simple. At the end, you'll get a disk image, and then the workflow that I have here, I actually just show you the template for it. The first thing it does, it wipes the disk, so we've retained that bit of logic from the original example, and then it installs the root file system. This should probably be called image hard disk, because what it does is it uses bash to download the disk image. And this is still a little bit of churn, but in effect, we're downloading the raw image and flashing it straight to the primary disk. Is that going to work if you've got a RAID array? No, because it's not going to be called dev SDA. But for getting something working, you can effectively create any kind of disk image you want, whether that's for CentOS or some other operating system. We dump that raw data onto the disk. We can then expand it to the size that's available. And it can provide a really simple, almost foolproof way of getting images on your machine.
That's really useful. Thanks, Alex. And I know that there's a bunch of energy in this area right now in the community, trying to get a simpler workflow. I think as Alex pointed out, this is being used at global scale inside Packet, and now we're trying to get it into a state that can be also accessed by someone who's just new to the space and trying to use it out for experimenting. And that's a struggle that we're working on, and I feel like we're getting there. One of the bits of feedback I've been getting from a few people in the community is that although Alex, and you'll see a few other people in the Tinkerbell community Slack channel, know a lot about this area, There were a whole bunch of people who were looking at Tinkerbell, and that included me until about 8 weeks ago, like, well, I'm sure we covered this in Comp Sci, but I don't really remember how it all works. So one of the things that we've done there, apart from some help from Alex within some internal training, was also to kick off a project inside the developer relations department at Packet, which is to create a glossary for this part of the stack, which is going to include not only definitions of what a lot of these terms are that you either don't know or maybe haven't seen, in like 20 years since, like me, but we'll also go into specific examples around there, because one of the things we're trying to do at Packet is get people excited around what we call layer 0, which is, down at this part of the stack, where we think some of the interesting action happens. So keep an eye out for that.
Now, I guess when I started to think about customization, one of the things that that you normally do with Docker is you isolate a container for its isolation properties. When you're running workers here, it's almost the opposite. You're privileged, you've got all of the disks mounted, you can do whatever you want to the system, and Docker just provides a good way of sort of packaging that. You do have some limitations, so you can't put, because OZ is running in memory, and it's limited to about, as we can see on the screenshot, the memory of the system, so 2 gigs. It's a 2 gig, I think it's actually a 4 gig Vagrant image. We can't actually put anything more than that on this system. So originally what I thought is, okay, I'll create my Packet image, I'll download it over the network, I'll unzip it, and then I'll flash it. And obviously that wasn't going to work, and I ran out of memory very quickly. So that's another thing, is to just think about the constraints of the environment. You can perhaps do things like, I think I tried to type Ellis BLK in here to list the bulk devices. That doesn't work because we're in Alpine. So if you use the Alpine container for your step, you also won't have LSBLK. So you may start to think, well, perhaps I need Ubuntu to run this step. And particularly the example that we migrated from Packet, you see there's this base image, and it installs all sorts of utilities and things like that, even Python and Build Essential. And so if you need a specific tool to run your workflow step, you have to think about building that into the Docker image. And ideally, for efficiency, you would then take that one base image and maybe have all of your steps derived from it, right? Because we need to think about the space available on the computer in memory. The Vagrant example is a bit more special, but when I ran it at home here, I had 16 gigs of memory to play with. Just bear that in mind as well.
I think people seeing this for the first time may be interested to know how they can get involved here.
Yeah.
I mentioned earlier about the community Slack. That's where most of the conversation goes on. If you want to get involved on a contributor level, I'd suggest you jump in there first to get to know people. But you can have a look at the GitHub project and see anything that's in there. We're becoming slowly better at labeling these correctly. We've got a slight issue in that the number of issues coming, and we have an issue in that the number of issues coming in has grown exponentially. But what we're trying to do is move towards a labeling system. Some of those I noticed have started to be labeled as suitable for beginners. Often they're documentation things, which may be a little boring if you're not that way inclined. I think there are probably some other technical things that can be done in there. They're typically the level of things that I try to pick up late at night when I'm hacking on stuff. And we're going to get better at that as we go. I suppose if you don't like Slack, there's an email address, which is hello@tinkerbell.org, that you can also reach out to. That comes to me and a couple of other people, and we can help point you in the right direction. But yeah, maybe Alex, you had something to add there, your experience of coming into the community as an external.
Yeah, so I mean, I think the community is obviously growing. There's a number of sort of partner companies like Kinvolk and Container Solutions that have been and OpenFast Limited that have been quite heavily involved from the beginning, sort of seeing it growing and have given a lot of feedback. But then there's also people that dropped in, I think, 2 days ago. You know, you mentioned one of the examples sort of breaking. Well, he sort of contacted me on Twitter. was asking lots of questions. I said, why don't you drop into Slack? And I can see he's been quite active there and sort of found it really welcoming and easy to get on with people. So I think, yeah, the Slack is a good place to be right now. One of the questions that I had recently from the community is, who's the target user here? Should Tinkerbell as it is today be considered for developers? Is it considered sort of pre-release? Is it for people to just go and put into production? Where are we today? Where are we going to be in 6 months?
Yeah, great question. So I would discourage anybody from putting this into production right now. Of course, it resembles closely the production system that we use at Packet, but it isn't the whole thing. And I think that's very important to keep in mind. The persona we're really optimizing for right now is the experimenter. Alex has gone ahead and done this on some Raspberry Pis. He's got the NUCs running down on the floor there, and we've seen a lot of other things like that. Now, that's not to say that we don't have aspirations to make this more production ready. And there is a roadmap discussed around adding things like data center inventory management, which I know various people have reached out to me privately to talk about. So it seems like that would be a next step to, to make this perhaps not Packet scale, but something you could run in maybe a couple of racks or perhaps with a whole bunch of NUCs at home. But for now, the focus for me, and hopefully this is shared across the org, is that we're going to focus on getting a very clean, easy to understand flow that will help you in a hobbyist environment to get working. And once that's solid and tested, then we can really start to look at some of the hardening features that would make it more suitable for production workflows. Now, I know that there are a couple of partners already looking into this for production workflows, and that's always going to be the case. I remember with Kubernetes back in early 2017, the instructions were very specifically to not run this in production, and yet some people did. And I think there's always an opportunity to move quickly with things like this, but of course, there's a risk that goes with it. Our recommendation is that you get up to speed on using Tinkerbell and understand how all the different bits work and engage with us so that we can together build a roadmap that's going to move it towards those bigger workloads.
Great. Well, I wonder, is there anything else? Probably some sort of questions that people are having as they're watching this, and ideas that you might be having as well, or you may be relating it to past experiences with other platforms where you sort of tried something out, it didn't quite work for you. Drop into the Slack. Feel free to ask your questions. There is also an interesting GitHub repo, I think, you can go off and look at, called Awesome Bare Metal. And that has a list of different projects in this area. Obviously, Packet are practitioners of bare metal. They've got servers you can run on if you really want to push the limits. And then there's an article on the new stack that I put together as part of that analysis, how to relate bare metal to cloud native. As you may be coming from a cloud native background and thinking, I thought I got away from servers. Why would I be interested in them again? Well, yeah, you can run this in VMs. That's what we did with Vagrant. You can run this on Amazon. You could probably run it anywhere. You don't actually need bare metal servers for this. It just tends to make more sense. So those are some further resources. We'll get a link for the recording, put them in there, and you can go and have a read. Maybe that'll whet your appetite.
Yeah, and I think based on the Awesome Bare Metal, it's been really encouraging to see. How many stars has it got now? It's like hundreds quite quickly.
Got a lot. Yeah,
a lot now. And it was really nice to see just how much action there is in this space. I know one of the things we've been doing sort of internally is reaching out to the different projects to as we call it, make the tent bigger. The way we're looking at this is there's a lot of excitement around what we're calling layer 0 right now. And with regards to these projects, some are newer, some are older, some have got different focuses, and we're really trying to bring a joined up message with all of them together there. So if you're watching this from one of those other projects, please do drop into our Slack. We'd love to chat with you and share notes.
Yeah, and I think there's also a degree of collaboration there as well, right? Dan, that is behind the Plunder project, and some of the other guys at Metal Stack and other projects sort of have an interest as well, and they're solving similar problems. And it's good just to see that level of interaction, like you see in the CNCF, for instance, where you've got all these similar projects, similar aims, and they start to cross-pollinate and influence each other. And who knows, maybe we'll have a bare metal camp online at some point in the future and sort of invite everyone along to it. Who knows?
Bare Metal Foundation.
Yeah.
Who knows? Cool.
Great.
All right. Well, this was really fun. Thanks.
Let's wrap it up there then. And this recording, I guess, will be available for people to come and view, and keep an eye on the GitHub repo. Go and star it.
Thank you.